My name is Sankirtana and I'm from CSCG section and my roll number is 24951A05Z5 and my topic is switching networks from the computer networks. Introduction to switching techniques. Switching techniques are essential for establishing communication paths in computer networks. Switching techniques determine how data is transmitted between devices in a computer network. There are mainly three types of switching techniques: circuit switching, packet switching, and message switching. Circuit switching dedicates a path for entire connection like a traditional phone call, and packet switching breaks data into packets and send them independently used for the internet. Message switching stores and forwards messages, and packet switching is one of the most common in the modern networks. Understanding these techniques can help us optimize network performance and resource utilization. Overview of computer networks. Computer networks connect multiple devices for data sharing and communication. Computer networks links multiple devices to enable data sharing and communication. They form backbone for information exchange in homes, business and organizations. Networks are classified into LAN, local area network, WAN, wide area network and MAN, metropolitan area network. Land covers small areas like offices or buildings. WANs span large geographical distances, often connecting multiple LANs. MANs serve cities and campuses, bridging LANs and WANs. Switching techniques are methods used within these networks. They manage data flow efficiently between them. Switching optimizes resources used and reduce congestion. Efficient switching ensures reliable communication and across the network. Switching techniques operate with these networks and to manage data flow efficiently. Importance of switching networks. Switching enables multiple devices to communicate over shared mediums. Switching is a network technique that forwards data frames between devices on the same network. It allows multiple devices to share the same medium without consent collisions. A switch learns the MAC address of the connected device to build a forwarding table. When a table frame arrives, the switch checks the destination MAC and sends the frame only to appropriate port. This selective forwarding ensures data packets reach their intended destination accurately. Unlike hubs, switches create separate collision domains for each port, reducing traffic congestion. Efficient switches minimize latency because frames are sent directly to the target device. By reducing unnecessary traffic, switching overall network throughout switches. Switches support full duplex communication, allowing simultaneous send and receive operations. Modern switches can perform additional functions like VLAN segmentation and QoS prioritization. Proper switching configuration optimizes packet routing and enhances network reliability. In large networks, hierarchical switching, code distribution access further boosts performance and manageability. Efficient switching reduces delays and improves network throughput. Types of switching techniques. Types of switching techniques refers to the methods network use to transmit the data between devices. There are three main switching techniques: circuit switching, packet switching, and message switching. Each technique has unique characteristics suited to different network characteristics. Choosing the right switching method depends on factors like cost, speed, and complexity. Circuit switching establishes a dedicated physical path for the entire duration of the communication session, like traditional telephone. Packet switching breaks data into small packets that are routed independently through the network. Message switching stores an entire message in a node and forwards it when the next link is available. Circuit switching. Circuit switching. It establishes a dedicated path between the sender and the receiver for the entire communication session. Continuous transmission. provides continuous real-time transmission with no interruptions, allocates resources exclusively for the connection even with no one use. Bandwidth is fixed and reserved regardless of actual data transmission. Circuit setup, data transfer, and circuit teardown. Traditional telephone network use circuit switching. Guaranteed bandwidth, low latency, and suitable for real-time applications like voice cells. And disadvantages are it is inefficient use of resources, costly for bursty data traffic. Connection oriented establishes connection before data transfer begins, not suitable for data networks with variable or bursty traffic patterns. This technique provides a continuous and reliable connection during the session. How circuit switching works. A dedicated path is established between source and destination during the uh, setup. The path remains reserved for the duration of the communication. Once the session ends, the path is released for the other user. The setup phase, a dedicated phase is established between the sender and receiver. Path reservation, network resources are reserved exclusively for this connection. Data transfer, data flow continuously through the reserved path with no interruptions. Teardown phase, connection is released when the communication ends, freeing resources. Making a phone call is an example. A dedicated line is set up for your conversation. A request is sent to establish a connection between sender and receiver. The network checks for available path and reserves resources. A dedicated physical path is set up between the two endpoints. Once established, data flows continuously through this path. Resources like bandwidth are exclusively allocated to this circuit. Other users can't access these resources till the connection ends. Data transmission is real time with minimal delay. Connection remains active even if no data is being sent. When done, sender initiates teardown and releases resources. Circuit switching is ideal for continuous data streams like voice calls. Advantages of circuit switching provides a guaranteed and consistent connection of quality. A guaranteed bandwidth. Dedicated bandwidth ensures consistent data flow. Suitable for real-time applications like voice calls. Suitable for time-sensitive applications like voice or video calls. Low latency. Minimal delay once connection is established. No packet loss. Dedicated path minimizes data loss or corruption. Simple to implement with predictable performance characteristics. Performance predictability performance, consistent performance as resources are reserved. Simple implementation, straightforward setup for dedicated connections. Disadvantages of circuit switching. Inefficient resources utilization as dedicated path remains idle. Inefficient resources, dedicated resources are tied up even when idle. uh, Not suitable for large data, costly. Resources are reserved exclusively, making it expensive. Limited flexibility, hard to accommodate bursty or variable data traffic. Scalability issues, difficult to establish many simultaneous connections. No error handling, no packet retransformation if error occurs. Long setup time. Setup time can introduce delays in establishing connections. Connection setup can delay start or data transfer. Packet switching overview. Packet switching divides the packets for transmission into packets for transmission across the shared networks. Data division. Data is broken into small packets with headers, address or sequence. Independent routing. Each packet is routed separated through the network. Shared resources. Network resources are shared among multiple packets or connections. Efficient use. Bandwidth is dynamically better for bursty data, error handling. Packets can be retransmitted if error occurs. Each packet can take different paths to reach the destination. Uh, Examples: Internet IP networks, email file transfers. The foundation of the modern data networks, including the Internet. How packet switching works. Data is broken into Data is divided into small packets with the source or destination address. Each packet is sent independently through the network. Routers read packet headers and forward them to the next hop. Packets may take different paths to reach the destination. At the destination, the packets are reassembled in correct order. If a packet is lost or corrupted, they can be retransmitted. They are reassembled at the destination and reconstruct the original message. Example: sending an email. It's broken into packets and routed through the internet. Advantages of packet switching. The packet switching advantages are: it is efficient resource use. Network resources are shared dynamically, handles bursty data, great for data with variable traffic patterns, cost effective, no need for dedicated connections, scalable, supports many connections simultaneously, support many types of traffic including data, voice and video, scalable, more scalable and resilient to network failures, supports many connections simultaneously. Error handling. Packet can be retransmitted if lost. Flexible routing. Packet can take alternate paths if congestion occurs. Disadvantages of packet switching. Packets Disadvantages of packet switching are: variable delay. Packets may arrive out of order or delayed. Packet loss. Some packets may get lost or in transit. Overhead. Packet header adds extra data overhead. And congestion. Heavy traffic can lead to network congestion. Complexity. Requires more processing for routing and reassembly. Not ideal for real-time apps or applications without quality of service or without guaranteed bandwidth. Message switching overview. Message switching overview is that uh, message switching involves sending entire message as a unit from source to destination. Entire message is stored at each node and forwarded when the next link is available. It stores complete message at the intermediate node before forwarding. No dedicated path, no continuous connection between the sender and receiver. Message handling. Are handled as complete units, not broken into packets. It was used in early network systems and less common today. Example: old telex networks and some email systems, suitable for sending bulk data, not in real-time communication. How message switching works. The complete message is stored temporarily at each switch or node. Sender sends a message to the first node, which is called as a switch. The node stores the message temporarily. When the next link is available, the message is forwarded. This stores and forward process repeats at each node. Message reaches destination when all nodes have passed it along. No real-time connection needed between the sender and receiver. This process introduces delays but simplifies routing. It is forwarded only after the previous segment is received or processed. Example: like sending a letter through the multiple mail offices. Advantages of message switching. Suitable for fixed length messages with predictable delivery time. No needed to establish circuits and maintenance stage formation. Useful in scenarios where bandwidth is limited and messages sizes are manageable. Disadvantages of message switching. High latency due to store and forward mechanism. Inefficient for real-time application. Can cause congestion if messages are large or traffic heavy. Comparison of switching techniques. Circuit switching guarantees a dedicated path, while packet switching shares resources dynamically. Message switching involves complete message transfer with delay, unlike packet switching. Choice depends on application requirements like speed, reliability, and resource efficiency. Modern applications and trends. Packet switching forms the backbone of the internet and cloud services. Advances like software defined networking, optimized switching processes, quality of service mechanism, enhance performance for real time data. Summary and key takeaways. Switching techniques are vital for efficient data transfer in networks. Each technique offers trade offs in a speed, resource utilization, and complexity. Understanding these methods help in designing and managing robust networks. These are the references I've taken. Thank you.